Yes.
Good.
Measurements versus
Listening.
listening. Yeah,
It's
this
always
is
interesting.
very, very interesting. I know you have done some uh, experiments on your side about cables.
I yeah.
Yeah.
I almost had a burnout after that test. It was crazy. Yeah, it was an enormous test. And some interesting facts. People always say cables don't do anything. And at least if I speak for myself, I can hear clear differences in speaker cables, interlinks, even power cables. I can't
Yeah.
explain why power cables make a difference, but we'll get there. Um, and I wanted to know why, because I'm always interested in if I hear a difference, can I actually clarify why there is a difference?
Hmm.
And that's really, really hard in our business. It's really hard.
So
But
what did you do?
do you have 3 hours? Let me
No, no.
put my
Well,
coffee
yes.
away. Um,
No.
first step is get help
Yeah.
because this is a very hard topic, and there are people that know way more than I do
Hmm.
about these subjects. So I called some friends, and they pointed me in a direction. Like, here you have some white papers, and here you have some scientific papers from the AES.
Yeah.
I read all of them, and I thought, wow, that's interesting. And one friend of mine, he helped out a lot. He's called Kees Ruitenberg from Sonnet Audio, and he makes his own decks. Wonderful stuff. But before he went into audio, he also worked in radar technology.
Uh-huh.
And so he knows a lot about how high frequency signaling and the importance of cabling, especially at high frequencies.
Hmm.
And he built a box because we were testing with cables, and yes, there were some differences, but if you measure a cable, you also measure your scope or signal generator or whatever you
Yeah.
use.
Hmm.
And it all had to do with grounding. So we had to build a box that actually disconnects the whole cable from the measurement setup. And that was an important step in
Yeah.
measuring cables. But he went even further because impedance is important. I don't have to tell you, you build speakers, so you know about impedance.
I do.
The impedance has an influence on signals. And also with cables, when you test cables, you have to emulate the environment in which you use it. If it's a speaker cable, you use
Exactly.
different impedances than with a signal cable.
Hmm.
And we could emulate all of that. And the moment we did that, it was a major step in measuring cables.
Hmm.
But still, yes, we noticed differences in geometry and length, connectors.
Exactly. Yeah.
But it's really hard to determine how musical it is. It's just not
Yes.
possible yet.
No.
There's still
No.
stuff
By
that
you
I
mean by
hear and can't
measuring?
measure.
Yeah.
Yeah,
Now you cannot
yeah,
measure musicality.
no,
No,
no.
but you can hear it.
But
Yeah.
the funny fact is, I could actually measure how dry or silent the cable is. That is
Aha.
possible.
Aha.
Yes, you could
But
see it in the uh, how steep the how do you say it, the spectrum diminishes after the
yeah.
pulse. So we send in a very steep pulse. I bought a 20-year-old HP pulse generator. I love eBay. And we could send in very steep high frequency pulses. And after the pulse, some cables took a long time to diminish, and
Hmm.
some cables were very fast. And you don't want it to be too dry. So if it's like, for example, a quad star cable, it's it cancels out so much that the actual presentation gets a little bit dry. And it could be correct, I'm not sure, but I didn't really like it when the pulse is there and it's completely gone afterwards. We want some energy in there to keep it fun and musical. But that's a matter of taste. But we could point out the cables that were very dry and the cables that were not very dry. And that was fun. That was a revelation for me.
Okay. Or did you do any blind testing?
Yeah. All tests were blind.
Okay. That is
yes.
great. Because that is actually the way that you can distinguish between what you hear and what you believe.
Absolutely true. Yes.
That is one of the things that I see, and one of the things that I will bring to the table in this talk.
Yeah.
Because there is a lot of science out there. We can measure many, many things.
Yeah.
And if we don't know about this science, if we don't have the knowledge, then we replace knowledge with belief.
Absolutely.
Because human beings cannot not know. So if we don't know, we replace knowledge with belief. And to me, that is, and for everyone, I think it is fine to believe something, but to know that, but to think that your belief is scientific, that's a gap. That's really a gap, well, actually, now I'm already off topic.
No, that's a very interesting one, because you're spot on. If we can't explain it, we start to believe. And I do actually think you have these platforms like Audio Science Review, and they do a wonderful job. But we turn it around. They measure, and if they can't measure it, they say it's not there. And I think it's the other way around.
Yeah.
I hear stuff and I want to know why. Because I've noticed in the past years that we started measuring that there is so much we can't measure, but we can hear it. And we did a lot of blind tests with power conditioning, with cables, with streamers, with DACs, because I knew what was playing. Oh yeah, network switches we did blind as well. I know what is playing, but Martijn or Jung or Jeffrey, that's sitting on a couch, they don't know. So I only swap the cable or the DAC or whatever, and they just listen. And we take notes. I take notes as well. In 90% of the cases, we write down practically the same thing.
Okay.
So our ears are incredible measurement instruments.
Yeah.
And I think we don't have anything to gain by saying A is better than B or C. I don't get paid for my reviews. I get paid for exposure. I give brands a platform they can use, but all of our reviews are actually 100% independent and honest.
And it has to stay that way.
It has to stay that way. And some people don't understand. I say, if I don't do that, I will lose all my audience. And you don't have a platform left.
No. Credibility is the island where you are standing.
And it's still a fight to keep it that way. But as soon as I can't keep that going, I will stop. Because I don't want to write advertorials. And that's why we started measuring as well, by the way, to send out a message like, we really want to know how this product performs. But the reason I wanted to have this topic is to say as well that measurements are only one part of the story. It's not the whole story. There's so much we can't measure yet.
Yeah.
But I was curious, you as a speaker designer, where do you see the measurements fit in? How much are you dependent on science in developing your loudspeakers?
We use measurements all of the time. We improve our measurements all of the time. We use better and better measuring equipment. It's really important for us to have measurements in order to know what we are doing. If we, if we succeed with something that sounds really, really good, we have to know by some kinds of measurements. So what is it that makes that difference? Although I must say that one thing that you don't know is that I originally come from a musical background. That's why that's why I started building speakers 40 years ago. So my way into loudspeakers and audio was from a musical point of view. And exactly as you say, there are things that we can measure and there are things that we can hear. And very often they correlate. So when we measure less bass, we can actually hear less bass. Some things are very, all of that is very, very basic. And then there is a big area of things that we can hear, but we actually cannot measure it. So that is why I started 40 years ago. I'm not going to get you into my life story, but actually I was very, very idealistic when I started. Too idealistic, but because I would not, people would not get any technical information. You could not see the drive units of the speakers. Everything was glued together because I did not want people to look at the drive units and say, oh, that's the tweeter I know from another speaker that I like. Now I already like your speaker, because the brain is also a part of the experience. And I wanted people to focus on the sound. So no technical information, no information about the drive units or anything. I wanted people to compare the sound and then make a decision from what they heard. And I have to say that is very idealistic, and it does not work in real life. And that was also 40 years ago. But still, this is an issue, because if you want to improve something, you have to know what you do. And measurements is a part of that. Normally, I say to the engineers that when we develop something, I'm the irritating guy. So when we develop something, we have some goals for what we do, especially from what we have done in previous times, and then we make measurements. And then some of the engineers will say, now we have made a better speaker because the measurements are better. And I will be the one who says, well, listen, now we only we are halfway. Now we know the material that we have, and we have everything described. So now we are halfway. I come from a musical background. So when you know how to play something, when we have agreed what the singer, the guitarist, etc., when we agree on everything, then we start all over. Then we start from the beginning again, and then we make it better. So that is what I give to the engineers, that maybe we made some decisions along the way with a product, and maybe we learned something in this development process, and maybe if we go back, we can look at the decisions we made, and then we can make them better because of what we have learned later on in the process.
So you see it more as a guide to know what you changed, what the impact is, and to improve on the next step.
Yes, we have to have measurements, but it is still, for us, it's still only 50%.
Yes.
Of the development process. I will show you something that you don't know either. I've written a book. This is Danish. Do you see the letters correctly? Or is it mirror image?
No, it's not mirrored.
You see it?
No.
Okay, but it's still Danish. This says, listen. The title of the book is Listen. And how to get started with user involvement.
Oh, interesting.
Yeah, exactly. The reason that I'm mentioning this is that some years ago, I had a completely open development process in a magazine online and as well as physical, in a magazine called The Engineer here in Denmark. They asked me, would you like to develop a speaker in an open space so people can see how it's done? And maybe they have some ideas, maybe they can just follow the process, or maybe they could volunteer to bring in ideas into this. And it was really fascinating. And one of the things that happened in the process was that companies volunteered to deliver services to the project, and we actually developed 2 directions of loudspeakers. I thought we were only going to make 1 loudspeaker, and if I was really lucky, a few people would join the project. But after 2 days, I had 110 engineers volunteering for the project. So,
wow,
it was. I was blown away. We after 2 days, I was sitting with suddenly the biggest speaker development department in the world for free.
Yeah, probably, yeah.
Yeah, and
That's
so
awesome.
I thought, with all of these people, we simply have to do something interesting. So I divided the project into 2 groups. The one that I call Evolution, and another that I call Revolution. With Evolution, you build on things you already know and you improve them step by step. With Revolution, you look at things in a completely new perspective, a whole new way of building things. And along in this process, there was a company called Sense Lab that asked us if they could join the process, if only I would publish whatever the findings were. And that was the whole idea with the project from the beginning, that I would
knowledge.
share everything, the success, the failures, technical drawings, everything that we made was supposed to be shared, because that was the whole idea on standing on a platform with 150,000 readers and viewers. So the idea was to make it completely open. And so when Sense Lab joined, it was for them an opportunity to get their work known to a broader audience of the engineering society within Denmark. So that was in it for them. But what we finally had the opportunity was to finalize our development of the revolutionary speaker and the evolutionary speaker, and then have it tested in a completely double-blind test environment. Because and it was the findings were many discoveries, and I will not get you into the technical details of the speaker, because that's not what we are here for, I think. But what we found was that we can hear many other things than we think. And and one of the things that we get fascinated about when something is revolutionary and new is that we expect for it to be better. We could not find a complete link from something new and revolutionary to better. And in this case, actually the evolution was better than the revolution. But that could, by far. And Sense Lab had they have a trained listening panel of people that come to the lab every week to train their listening abilities. You know, if you cannot repeat your what you hear, you are not a reliable test instrument. So they have to keep training and they always do blind tests because it's the sound that they compare.
Yeah.
And so I think there are 35 people. So they call them in, they listen to differences in headphones, in car doors when they are closing car doors, the sound of the closing car door.
Nice.
And,
Yeah.
you know, and but especially something within the audio industry.
Yeah.
So for this particular project, it was fascinating to see that in this case the evolution was better than the revolution. Other cases would be different, and that kind of open-mindedness is what I was talking about when I talk about a belief. Do you have a belief or do you have science? For me, it's fine if someone say vinyl is the original best sound. If someone says I prefer vinyl, I am fine with that.
Yeah.
No problem. And but it could rely on a belief, because, you know, I could say to someone saying like that, it's fine, let's just stop by here. But you should know, when you say you prefer vinyl, you should know that vinyl records are not the same. They are different.
No. Yeah, true.
And turntables are different.
Yeah.
Cartridges, tone arms, the whole system is different. So when you just say vinyl is better, it's a very narrow perspective.
Yeah, but the same applies to streamers. Every streamer is different. Every deck is different. Every server is different. Even Tidal sounds a little bit different than Qobuz, and it sounds a little bit different than your files on your NAS drive. So there's so many variables.
Absolutely.
That you need to keep
music
in mind.
has absolutely, and it's not that it's not okay to say
no.
Vinyl is the best. That is completely okay. But I think that if you're interested in this area, I mean, if you want to move ahead, or if you think it's interesting, then knowledge has to be put in somewhere. And you have to know that vinyl is many, many things. Have to know that turntables are many things, and music has been recorded digitally since the 80s.
The 80s, yeah, true.
Yeah, it has. So when you have a vinyl recording, you might very well have an original digital recording if it's if it was originally made in 24-bit 96 kilohertz. The dynamics could be up to 144 dB. So when they made that into the analog version, it will be reduced to 60, 70 dB. They will change something like that. It will be reduced. The tracks on the inside or closer to the center of the record will have less treble than on the outside because of noise, etc., etc. But still, that is no problem for anyone to say they prefer the sound of it. I have no problem with it. I just think that it's nice to have the knowledge put on top of it.
Yeah, I agree. And I can confirm that most vinyl records have a digital master. Where our office is actually in one of the biggest vinyl pressing factories of the world, I think, record industry in Haarlem. And I know that most masters are just delivered on a USB stick.
It is.
And they are remastered for vinyl, and they do a great job here, and it sounds wonderful. But it's still a digital source.
Yeah.
And I know that it sounds different because I've compared the vinyl record to the files on the USB stick, even the vinyl master. But as soon as you have the vinyl master and you play it on your streamer, it sounds almost the same as the vinyl record.
It does.
It's just the master is so different from the CD master or the high-res master. I was like, wow, this sounds incredibly good.
So you say that it's actually not the material.
No, it's not the
actually
medium, the master.
Uh-huh.
It's
okay.
I couldn't share those files because, of course, of copyright and stuff like that. But it was really, really interesting and funny to hear the vinyl master in wave on a streamer and then the vinyl record. I was like, this is what they're talking about. It's just the master is just nicer to listen to. That's it. There's nothing to do with digital.
And you can like that, and you can prefer that.
Some are better.
Yeah. We have had 14 vinyl fairs in our loudspeaker factory.
Oh, wow.
Twice a year for quite a few years. It's the biggest vinyl fair in Denmark. We have that here in our loudspeaker factory. And I must say that meeting music enthusiasts, vinyl enthusiasts in real life, talking about the music and is this version better than the other version, and do you have etc., all of these conversations and this physical meeting with people is just so much more interesting than when you're sitting with your smartphone and showing off your playlist. That it is another thing. I must say that I could not imagine a streaming fair with people sharing their
do you have this version?
It's
different.
Not,
I know
it's not the same thing.
Now I love all sorts of music, and I'm pretty much agnostic to the source. I can enjoy vinyl. I just think it's not for me because it's too much hassle to flip a record and find the right master. But when I hear a good piece of vinyl, it sounds incredibly good.
Yeah.
But what people forget is that you have to compare apples to apples. You can't compare vinyl to streaming because there's just too much difference in that. And going back to measurements, if you measure a very good turntable, it will always measure worse than a streamer or a DAC.
Yeah.
But the whole thing is, we still enjoy the sound a lot.
Yeah.
And that's fascinating.
And why is that?
And why is that? I think it has to do with the fluidity of vinyl. There's just no intersample distortion or anything like that. It's a very natural distortion that we listen to. We're used to that. Probably if you go walk in the woods or listen to music in real life, there's a ton of distortion out there. But we got used to it. We can handle that. We understand that. But digital distortion is very, very unnatural. That's the whole thing.
Can I share something nerdy with you?
I think that's what we're talking about.
Okay.
This wasn't nerdy enough. Nerdy. Okay. Now it gets nerdy. Let's go.
That was. No, I would like to talk about three things where I think measurements collide with listening, and where there is some really interesting things that we don't talk about anymore, or we don't know about it, or anyway.
Yeah,
I have here a woofer.
Yeah,
the woofer has got a membrane, and obviously, and one of the things that many people are not aware of is that how the material of the membrane affects sound. Way back in the 70s, we had more powerful amplifiers with transistors and stuff like that. So with more power from the amplifier, speaker designers could start looking at how to improve speakers, because they didn't have to be as efficient as before when amplifiers were very low powered. So with very high power amplifiers, speaker designers could start looking at how can we improve the performance of the speaker. And in those days, that was something that you would try to do with measurements.
Yep.
So I think that happened in those days was that paper membranes from old-fashioned speakers were replaced with softer membranes. Diaphragm is the name. You probably, if you think about a speaker like the Rogers LS35A,
Yeah.
it was
Yeah.
one of the first speakers with membranes of a material called Bextrine. It's a kind of plastic membrane. And
Harpeth uses stuff like that as well, I think. Some sort of
some sort of
artificial...
soft material. There was a big development into materials in those days. And what it did to loudspeakers was that these membranes would have a high internal damping.
Yeah.
So the frequency response of the speakers were much smoother compared to before. And that set off a whole direction of speakers with different types of membranes, and we see it today. And what I will point this down into a very simple listening experience, because you can take the membrane, the internal damping of the membrane material, and you can there's a link to that and directly into the sound. Because very often with high internal damping in a membrane, you will have a sound that is much smoother, but also more laid back. A harder loudspeaker membrane, it gives more color to the sound. The response is not as nice, but the sound seems as if it's popping more out of the speaker. So there is something here, exactly what you showed. There is obviously a balance here, that you cannot just go for the perfect response of the speaker, because that would give you a more boring sound. Now I say boring, but a more laid
back, calm.
Yeah. Still, you can prefer that.
Yeah,
that's not an issue. I just say that there is a correlation between a harder membrane and the liveliness of the sound, and the softer membrane and the smoothness of the sound. So as a speaker designer, there is a balance between those two, and about how to balance out the liveliness of the sound and the smoothness of it. Because here is something that cannot be changed later in the process. It doesn't matter which cable you have or which amplifier you have. If you have a laid-back sound speaker, the sound will never be live. If you have a very live-like speaker, it will never be laid-back.
Does it have to do with the resonance pattern and maybe the type of distortion, like which harmonic is dominant in the speaker?
It does. Absolutely. And when you said, when you're told about the difference in the cables, it's about when it dies out.
Yes.
How soon does it die out?
Exactly.
When the sound ends in the speaker, when does it sound? Yeah. How soon does it? And that is very, very audible, and it is very hard to find a link between measurements and what we hear. But we hear it very easily.
Oh yeah. Yeah, I remember one test I did with Hans Beekhuizen, my colleague. He lives pretty nearby. And he had a network filter. And that was really, really funny. Because he said, can you measure this? And maybe I said, I have some form of a setup. It's kind of experimental, but we can try. And we were, I think, measuring for 3 or 4 hours.
Oh and
it's really, really hard because we were looking and we couldn't see. Eventually we had something like, it does something, and this is, I think, what it does. Jitter was a little bit lower and stuff like that, but it was really hard to find it. And we sat down, I switched the filter, and without filter, I think it took us 2 or 3 minutes to hear the difference.
Yeah.
It's like, just sit down, play. Yeah, that's it.
Yeah. There it is.
Instantly.
Yeah.
There it is.
Yeah.
And we were looking at each
Five,
other.
five
Like,
hours. 5 hours on one side, and 2 minutes on the other.
it's stupid. It
Yeah.
took us hours of experiments, and I think I've been trying to measure network stuff for years now. And now I have
Yeah.
a setup that actually works, but it took me, it was pre-COVID even that I started looking into this. Imagine.
Yeah.
Yeah. And so that's a couple of years of investigation. Like, what does it actually do to your hi-fi system?
Wow.
And I think I have like 300,000 euros of equipment in there. Not I didn't pay that, but it's all found on eBay. But if you had to buy this gear, it would cost you 3.5 tons, 350,000 euros of equipment to actually measure it. And
Okay.
you can sit down and you can hear it in 2 minutes.
Yeah.
That's it.
So
it's
so
stupid.
yeah. So what's important?
What's important?
Yeah.
Just trust your
Yeah.
ears. But
Yeah.
that's what I try to convey my readers. Like, yeah, we investigate stuff because I'm a nerd. I want to know why. I love to investigate stuff. But as a consumer, it's just not that important to look into this.
Not unless you measure on your equipment in your home, and that's why you buy it. But I hope that people will prefer listening to music.
I say so. And
Yeah.
I have a lot of feedback like, yeah, but you can do this. I say, I don't listen to test tones. I don't listen to white noise
No.
for fun. I listen to music. And you can really, really trust your ears on this. And yeah, we investigate stuff to know more and to help the industry maybe a little bit by giving feedback and explain why stuff works or why it doesn't work.
Yeah.
And I try to help out my readers and also, of course, the industry by measuring cables and explain why cables do stuff. But in the end, as a consumer, it's just not important to rely on test reports because they only tell half the story. But I was just interested in how you, as a designer of loudspeakers and other gear, rely on measurements. Is it like a guide, or is it something else for you?
It's a guide, and for us, it's a way to document to ourselves what we're doing.
I think that's
That-
an important one.
I had two other things that I think is important,
Sure.
The first one was about the internal damping of speaker membranes, because it's very, very audible and important to the experience. Another one is also actually also originated back in the 70s, where especially Japanese manufacturers came into the market with amplifiers.
Yeah.
And
Like Accuphase and Denon and
Sony,
Onkyo or
all
Sony,
of those
of course.
names,
Yeah,
all of
yeah,
those names, they came into the market by talking about technical specifications. And they would show that this new product will have distortion of like 0.000 whatever many zeros. And then the new one, exactly. That's the whole issue. The new one would have even less distortion, so it must be better. But then in Finland, now I'm pointing in that direction.
Finland.
That's where Finland is. In Finland, there was a professor called Matti Ottala who found that lower distortion is not necessarily better.
No, it isn't.
Because there is a distortion generated from the feedback, just as you said, the feedback loop where you reduce distortion increases other kinds of distortion.
Yes.
And that was his work, and suddenly there was a new movement after when he described this transient intermodulation distortion. I think that was how it would Yeah, exactly. Really nice name. If you want to
Yeah,
scare people off, just say that and
yeah.
yeah, put it on the internet, and
Intermodulation
you are
distortion is very nasty.
yeah,
It's
yeah. But
horrible.
and he proved that there is actually a balance. Again,
Yeah,
how much feedback, how much distortion can you live with? Because you don't want as little as possible. Because again, amplifiers with almost no feedback will have a sound experience where again the sound pops out of the
it
speakers.
does.
It's the
Yes.
same kind of development that happened in those days, where speakers have reduced distortions,
Hmm.
amplifiers had reduced distortion, and if you put those two together, you have extremely boring hi-fi systems. I think it's the
That's the whole
balance.
thing. It's the
Yeah,
balance, and that's
yeah,
what why I think these big Excel sheets are so dangerous. That, well,
yeah.
you know the website, I think, uh, which just lists the CNOT, signal, and noise and distortion.
Mm,
So it's just one number, but it doesn't say anything
no,
about the musical performance of that amplifier or deck or whatever. I've
no.
measured my Pulse Labs amplifier measures worse than the Hypex Nili that I have as well. But I
Okay.
think you can kind of predict which amp is actually more enjoyable to listen to. Um, and that's the whole thing. Nelson Pass found the balance between how much feedback do I need
Mm,
and how does it actually sound. And I'd noticed as well that high feedback amplifiers are actually pretty boring. And it
yes.
depends on the implementation, but if you just use too much feedback, it's not enjoyable anymore. It's
No.
just dry.
Yeah.
And yes, it sounds very correct, but it's not enjoyable. Like the stereo image becomes flatter, and we all know what happens.
Mm,
And the Postlabs uses very, very little feedback, but you can see it in the measurements that it's just not as quiet as the Hypex Nili.
no.
It's just the trade-off you do. And that's
Yeah.
why I never publish CNOT or signal and noise and distortion values. I don't care. It's just a number, and some have
Yeah.
86 dB, some have 110 dB, and whatever. But what I do found very interesting in the speaker measurements is the distribution of the distortion, like the second, third, fourth, and fifth harmonic. Where
Yeah.
are those? And that's what you can really hear. The frequency response is not that interesting, actually. It's just how it's tuned, and if it's laid back, or the English
Yeah.
BBC curve or the
Oh
Harman
yeah.
curve or whatever.
Yeah.
Uh, but the amount of
The
distortion is really audible.
It is absolutely, and but also the power response of the speaker, the amount of
Yes.
energy that it puts into the room, not
Yeah.
not like you said, the on-axis
Yeah.
measurement is actually not very interesting. It's the amount of sound energy that is projected into the whole room that
Yeah.
is something that you can hear much, and distortion, like you said, much more easily
Yes.
than
It is.
on-axis.
Yeah, that's where I
Um,
found the real differences. If you've way more experience in measuring speakers than I do, I'm sure. But when I had a couple, like 20 or 30 loudspeakers in the database, I noticed that the frequency response is not interesting at all. It's a matter of tuning. Brand A
hmm,
does it like this, brand B does it like this. And if they're coherent, all speakers will actually have kind of the same curve. But the
hmm,
distortion pattern is interesting to look at.
yeah,
Like, is the
and
third or the second harmonic dominant? And that's what you instantly
yes.
hear.
Yeah,
It's
and at which frequencies they are dominant, and how dominant
yes,
they are, etc.,
yeah,
etc. And
yeah,
that is the kind of specification that you will not find on the internet.
no,
You will
you
not
don't.
find. No. So,
No,
so what you see is something that makes no sense in terms of
no.
hearing any difference. Yeah.
That's
So
a
I
good
promise
one,
you a third.
actually. Yeah,
Yeah.
you don't see those measurements online, and I get that
No.
because it took me quite some time to find it
Mm,
and to interpret it because you can see a graph. It's like, yeah, that's interesting, but what am I looking at? That's the first question I ask myself. Like, okay, I have some numbers. What do they mean?
Yeah. And if you cannot
uh,
compare it with other manufacturers, then it doesn't
say
make any sense
anything.
anyway.
No, doesn't. And if you just feed it to a consumer, like, the third harmonic is dominant at 1500 hertz. Like, that's interesting, but what do I have to make of that? That's,
exactly.
It's hard, but
I just
it
want
is
to hear
interesting.
Yeah.
Just want to hear music.
So exactly. So could you play some music instead of that?
Play some music.
Third, I have a third and last thing about technical stuff and how it works on our listening experience, and that is I have a piece of paper here. Thiele small parameters. Very. This is really This is now it gets nerdy. Thiele small is
nerdy.
It is, but this is probably the most audible thing on a system ever.
Now I'm going to learn something because I never understood that.
No, okay. So Thiele small parameters are electromechanical parameters that determine the low frequency response of a loudspeaker. There are, and the Thiele small, now I'm showing you the woofer again. Thiele small is really about, it's a way to make it an equivalent of everything electromechanical in the speaker. So the area of the membrane is a piece of a mathematics. The strength of the magnet, the voice coil, the moving system, everything in the woofer is translated into numbers that go into these parameters that are called Thiele small. They were two Australian physicists, and they described Thiele small parameters, and then new engineers have found more data that you can use. So there are, I think it's called extended Thiele small or something like that. There are 22 numbers, something like that, that describes the low frequency response of a loudspeaker. And when I say 22, already you get blurry, So what is most important, what is audible and what is not audible, etc., etc. So what I've done here on my piece of paper is that I've boiled everything down. Can you see this?
3. That's good.
I've boiled everything down into 3 things that have to do with Thiele small parameters, and things that you can hear, and things that have influence on a loudspeaker design. Okay. So basically, Thiele small parameters describe the precision of the sound. Again, the speed that we talked about. Now we call it speed. Here I call it precision. The how deep the loudspeaker go in frequency, the resonance of the system, how deep does it go, and the efficiency of the speaker. These, as a speaker designer, you have to this is a piece of cake. You have to decide what is most important, what is less important, and what do you want to present in your speaker. You cannot say I want to make a very, very efficient speaker with very deep bass and which is very precise. You cannot, if you say very, you make the piece of cake bigger and then you have less of the others.
It's a trade-off.
Yes, exactly. It's a compromise. Now I will remove the piece of paper because I went to our System Audio Museum before I came to the computer. And here are 2 old speakers, a small one and a bigger one. And when you look at these 2 speakers, you would, your intuition would be like the bigger speaker would have deeper bass. That is what you would expect. But actually, it might not be the case. It
No.
absolutely might not be the case, because if the smaller speaker has been designed with more focus on the frequency depth, it could actually have deeper bass than the bigger speaker. If the
but
bigger
at the
speaker
trade-off of
is
efficiency or
yeah,
yeah.
I will not.
Okay.
I don't think I will. I will use this occasion to mention other brand names, because
No.
it doesn't matter. I just want to say that this is. You can see it.
Yeah, perfect. Yeah.
This is science. This is what it is.
Yeah.
So if you have a very, very efficient speaker, it could have very deep bass, but it would not be very precise. You could have a very precise speaker, but it will not be very efficient, maybe, or it will lack depth of bass. What can I say?
That makes
Bass
really
reflex.
a lot of sense. Yes, it makes a
does.
lot of sense. Yes.
We can compare bass reflex to a sealed chamber. Bass reflex will add depth, and it will add efficiency of the speaker, but the speaker will lack precision. If you want to have
Definitely
a more precise speaker than bass reflex, it will have to be a sealed system, but then the trade-off will be efficiency and the depth of bass.
True.
If you build a horn speaker, you will have a lot of efficiency. That will be big, but the bass will not be very deep, maybe, or it will not be very precise. That depends on the design of the whole system.
Yep.
So
Yeah.
if someone say they have done everything, show them this.
Where is your trade-off?
Yeah, yeah.
That's not possible.
Yeah,
no,
exactly.
I know, because I have active ATCs at home. I've tested the passive one as well. It's a closed system. It goes not very deep, and I know they're very hard to drive. So, but it's extremely fast and precise in the bass.
Yeah, yeah.
And
now you know why.
That's why. That's what I said. Like, this makes a lot of sense. Once you've seen this, this really helps. Because I've seen it with bass reflex speakers as well. Some go very low, but they're not efficient. It's always a balance. And I've never heard a speaker with all three of them. At least not in my years.
No. There is trade-offs. So again, we come back to the same conclusion all of the time, that listen, because that's what's really important.
Yeah, I've noticed it, but I've never actually seen this or tried to measure it in some ways. But you can hear it instantly. Yeah. So I think on that bombshell, we talked a lot enough about nerdy subjects like measuring, and the conclusion is always the same. Yeah, just listen. Trust your ears.
Listen. Yeah, in Danish,
listen. Listen.
Yeah.
But thank you for your time. It was an interesting podcast. People know that I really like this subject as well, but you enjoyed it as well, I think.
Absolutely.
Considering your preparations. Next one will be interesting, and it's actually quite the same as your pie over there. It's smaller systems versus larger systems. Where are the trade-offs, and how do we experience it?
Yeah.
So
for now, I think we'll say see you next time.
See you next time.